Well, for the project 2, we need to look at the report result of Abby's blood test component. Okay, result. So first half, you actually have 2 sections. The first section, you find the probability that Abby's result is below the average, below the mean for the population. The second section, you calculate the probability of the result, which Abby's result is bigger than the mean of the population. So, for example, the first one, Abby's result is 1.5, which is way below 7.5, and the standard deviation is 1.25. This is the mu, this is sigma. Okay, and the second one is also below. This third one is also below. The fourth one is also below, but next one is above. So this is the 95 should go to the second section, right? So the first 4 will go to the first section for sure. I'll give you one example how do you do this one. So Abby's result is 1.5. We find out the z-score. Z equals 1.5 minus 7.5, 1.25. So the probability that z is less than equal to 1.5, which is probability, x, the experiment data, z is less than equal to 1.5 minus 7.5 over 1.25. So got a p, z is less than 6 divided by 1.25 equals negative 4.8. It's almost it's more 0.00, a lot of zeros. Okay, 4.8. So it's gonna be a very small number. It means what? It means, well, only very few people. Only very few people will have the white blood cell content is below 1.5. So which means Abby have a big problem with his white blood cell count, because it's way below 7.5. Only 0.00% of people will have this happen, but it happened to Abby, which means she needs to pay attention to his white blood cell count, right? Okay, this is for the below average. What about the above average? For example, we look at his glucose serum, okay, which is above. Okay, for the above one, we look at the above one. His is bigger than, we look at it bigger than equal to, okay, because it's above the average. So Abby's result is 95. Now we look at the z-score. Z bigger than equal to 95 minus 79.5. Take this one as example, over 9.75. So if it's above this number, what do we got is 95 minus 79.5 divided by 9.75, which you got 1.59. So probability of z bigger than 1.59. So what happened for this one is probability is 1 minus z less than 1.59. What is that probability? 1.59 according to the normal distribution score. Let me calculate it. Normal distribution calculator. Okay. So 1.59 mean area probability is above 1.59. Okay, so it's is going to 0.0559. Okay, 1.59 is going to be that. So this means what? This means for a person whose glucose serum component, for a person have this is way above 79.5, the probability is really small. So Abby should pay attention to this part too. because that's just a very few people will have this higher than 95, but it happened to her, so she needs to pay attention. When it's above the average, you look at the probability above. When it's below average, you look at the probability that is below average result. What's the probability that is below her result? Okay, so this is how you do this. You find the probability for all of them. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you have to do 17 probabilities. Find out the ones which is very unusual. Okay, find the ones which was very unusual for Abby. So some of them is kind of okay. For example, maybe 0.8. If this one should be fine. The sodium 143 minus it divided by this is part is okay. Okay. So you find all the probabilities. Okay. If it's less than, find the probability less than Abby's result. If it's higher, Abby's result is above the average, find the probability that is above Abby's result. Okay. So then find the probabilities and make a report, write a report. Okay.